In December 2015, 195 nations around the world adopted the Paris Climate Agreement. It was hailed by Barack Obama as the best chance we have to save the one planet we've got, and has been embraced by almost all countries around the world as the key to tackling global warming.
The growing threat of climate change could define the contours of this century more dramatically than any other.
Dr. John Robson is a historian and a professional journalist who's investigated public policy issues in Canada for decades. He's used to asking the hard questions, finding the solid evidence, and separating fact from fiction.
The Paris Accord is a major treaty. It sure sounds impressive. But 2 decades earlier, similar praise was lavished on the Kyoto Protocol, which was also signed by countries around the world. Remember that one? By the time it expired, in 2012, most countries had abandoned their pledges, and Kyoto was universally regarded as a costly failure.
Will Paris be any different? Have we learned anything from Kyoto's cruel disappointment? Or, once we get past the self-congratulatory cliches and start looking critically at the details, will we discover that it has the same structural problems as Kyoto, and its failure looks inevitable for all the same reasons? Before we throw any more billions of dollars at it, we need to ask some serious questions about how it's meant to work and whether it possibly can.
I'm John Robson for the Climate Discussion Nexus, and this is a CDN backgrounder on the Paris Climate Agreement. Climate change is a serious topic, and the Paris Accord is a major treaty, and we want to deal with it systematically. In the first part, I'll look at why carbon dioxide emissions have proven so difficult to control in practice. And in the second, I'll show why the same computer models that claim man-made global warming is a major problem also say treaties like Kyoto and Paris won't help.
Before getting into the details of the greenhouse gas issue, let's look at an earlier environmental problem we were able to solve. Acid rain was a big worry back in the 1970s. The concern was that emissions of sulfur dioxide, or SO2, from power plants and large industrial users of fossil fuels, like coal, oil, and natural gas, were killing trees and poisoning rivers and lakes. Many decades ago, regulations were implemented to force polluters to clean up their SO2 emissions. And they worked because, fortunately, engineers were able to develop scrubbers that filtered almost all of the sulfur out of smoke before it was released. As a result of this technology, our emissions of SO2 were reduced drastically, even while our energy use and economy continued to grow.
So, the sulfur dioxide story had a happy ending. But now, let's change the S in SO2 to a C and look at carbon dioxide, or CO2, the greenhouse gas at the heart of global warming concerns and of policy responses. Plot spoiler, there's no happy ending here, mostly for technological reasons.
Like SO2, CO2 comes from burning fossil fuels. But there are 2 key differences that make reducing CO2 emissions far more difficult. First, there are no scrubbers for carbon. Sulfur comes out of scrubbers as a solid, which can be turned into usable products, like fertilizer or gypsum, or at worst, disposed of in a suitable landfill. But unfortunately, while CO2 can be extracted from smoke, it emerges as a gas and not as solid carbon. Which means there's really no way to dispose of it, other than releasing it again, which defeats the purpose. Sometimes people try pumping it underground, so-called carbon capture and storage, but that's very expensive and impractical in most cases. It amounts to trying to stuff gas into a hole in the ground and hope it doesn't seep out again.
You see the problem. Because there's no practical way to get the carbon out of CO2 or to burn fossil fuels without releasing CO2, the only way to cut human CO2 emissions significantly is to cut our fossil fuel use significantly, which is extremely painful because fossil fuels provide most of the energy we use worldwide. Sulfur scrubbers let us reduce SO2 dramatically while fossil fuel use went up and economies continued to grow. Cutting carbon dioxide means imposing real, dramatic hardship on people around the world.
The second difference between SO2 and CO2 is that sulfur dioxide was a local pollutant with negative effects that people could see with their own eyes. So they demanded policies to clean up the air where they lived. But whatever its effects on global climate, high local levels of CO2 don't cause local problems. Not even inside of cars and offices, where it's often 4 times as high as outside, and nobody even notices. And that means it's hard to convince people that they should bear the costs of cutting emissions when other people in other countries aren't. The Earth's atmosphere is over 99% nitrogen, oxygen, water vapor, also a significant greenhouse gas, by the way, and argon. CO2 is currently 4/100ths of 1%, or 400 parts per million, only about 1/25th the level of argon. But CO2 is harmless to humans, even at far higher levels. In cars and offices, it typically goes over 2,000 parts per million of CO2. The breath that we exhale contains about 40,000 parts per million of CO2, 100 times the ambient outdoor level. But we don't poison each other just by breathing.
So, you might wonder, why are we trying to reduce CO2 emissions? Many scientists are concerned that increased CO2 levels in the atmosphere are having an effect on the global climate, particularly that they're causing it to get warmer.
Human global emissions of CO2 and equivalents from fossil fuel use and cement production are about 10 gigatons per year. Of that, they say, about 5 gigatons gets naturally absorbed or sequestered by plants and the oceans, leading to a net addition of about 5 gigatons to the atmosphere each year, which raises the average global CO2 concentration in the air by around 1.5 parts per million annually. So, in order to stop the CO2 concentration from rising due to human activity, our global emissions of CO2 and equivalents would have to fall by about half. Kyoto aimed to achieve that result.
But because there are no feasible carbon scrubbers, that reduction would have required us to cut global use of oil, coal, and natural gas by almost half. And the catastrophic real-life consequences of attempting such a reduction did overwhelm and will overwhelm the best of intentions.
In 1997, when Kyoto was signed and everyone was all excited, global carbon emissions were about 6.5 gigatons. Developed countries promised to cut their emissions by about 15% to just below 1990 levels by the year 2012.
But when they realized how costly it would be and how futile if developing countries didn't follow suit, they simply abandoned their pledges in practice while continuing to affirm them rhetorically. By 2013, human global emissions hadn't fallen at all. Instead, they'd risen to nearly 10 gigatons. That's failure by any definition, and it gets worse because the next big question is, what would have happened if every Kyoto signatory had followed through on their pledges?
Here, the truth really hurts. In the next video in this series, we'll show you that the very same models used to forecast global warming showed that full implementation of Kyoto would have had almost no effect on the level of CO2 in the atmosphere over this century, and therefore on the global climate, which those models insist is controlled by atmospheric CO2.
And as I'll show in that video, the Paris Treaty has the same structural flaws. No practical way to reduce carbon emissions without slashing energy use disastrously, and no measurable impact on the climate, even if we do. There really is no way to make Paris sound like an achievement once we look at the facts.
So it's time to challenge the empty slogans with facts. That's what the Climate Discussion Nexus is all about, and we're inviting you to be a part of it. Join the discussion online at climatediscussionnexus.com. And if you like what you see, visit our Patreon page and sign up to be a supporter.